All right, so let's go through section 4.2, proving and applying the sine and cosine laws for obtuse triangles. You will not have any problems with this, or you shouldn't have any problems, because we've already done this with acute triangles. So same sine and cosine law that you already know. We're just going to think about how is that going to be different in obtuse triangles. So it says you can use the sine law with acute or obtuse triangles when you know, first of all, the lengths of two sides and the measure of an angle opposite one of those sides. So if you have the length of two sides and the angle that's opposite, you can use sine law because you have a set right here. And that's when we use sine law, if you have a set. Or if you have the measures of two angles and the length of any side. So the measures of two angles and the length of any side, there's that set as well. Okay, so set equals sine law. Now, cosine law. What do you need to have to use cosine law? Hopefully you're thinking the word contained. If you have a contained angle or you're finding that contained angle, you can use the cosine law. So it says you can use the cosine law with acute or obtuse triangles when you know, first of all, the length of two sides and the measure of the contained angle. There it is, the length of two sides and that contained angle. Or you know the length of all three sides. Because if you know the length of all three sides, then you're finding an angle and every single angle would be contained. All right, so let's go through two examples using the sine or cosine law on obtuse triangles. And the first example says determine the angle of measure C to the nearest degree. So it doesn't say to use sine or cosine law, so you have a look at what you are given. I'm given two sides and I'm given this angle over here. Now this angle is not contained between 11 and 9. This right here is the angle that's between them and you're not given it. But you are given a set right here. You have 48 and you have 9 across from it. So since you have a set, you are going to use the sine law. So set up your sine law and say the sine of 48 over 9 is the same as the sine of angle C, that's my unknown, over 11. Remember that I want to find angle C, so right here is my unknown. That's what I'm looking for. That's what I got to solve for. So when we cross multiply, we're going to have 11 times the sine of 48 equals 9 times the sine of C. Okay, sine of C is what I'm finding, so it's that 9 that I got to get rid of. So I need to divide both sides by 9. When I do that, I isolate the sine of C because that's what I'm trying to find. So I know the sine of C is the value of 11 times the sine of 48 divided by 9. 11 times the sine of 48, press enter, divided by 9. And that's 0.908. So if I know that that ratio is 0.908, I can find angle C by finding the inverse of 0.908. So go back to your calculator and we'll go second sine of that 0.908 and I get 65 degrees. All right, so have a look at this angle. Does it look 65 degrees? It's an obtuse angle. It's obtuse, you can tell by looking at it. Okay, it's way bigger than 90 degrees. And remember what you know about sine. Remember what you know about sine ratios in quadrant 1 and quadrant 2. Okay, so what am I talking about quadrants? Remember we went over that in 4.1. If I were to draw, let's see, let's get rid of some stuff. Hold on a sec. Let's get rid of all this going on here. And if I were to draw just a pretend y-axis, let's see if I can get it kind of straight, y-axis, an x-axis. Look at how big this angle is. It's way past 90 degrees, okay? And remember how we talked about that the sine in quadrant 1 is actually the same in quadrant 2. I went over that a lot in 4.1. So if you don't understand that yet, you really need to come and talk to me about that, okay? So in quadrant 1, sine is positive, remember, because it's opposite over hypotenuse. And in quadrant 2, sine is positive because it's opposite over hypotenuse. So there's no way this can be 65 degrees. It has to be that angle that ended up in quadrant 2, which is more than 90. So to calculate angle C, you have to realize that it's obtuse, and so the way that you calculate the obtuse angle is subtract it from 180. So when we subtract 65 from 180, we get 115. Therefore, angle C has to be 115 degrees because it's obtuse. Okay, example number 2. It says determine the measure of angle E to the nearest degree. Okay, here's angle E right here. Another obtuse angle, more than 90 degrees. All right, so let's take a look at what I have. I have 3 sides. 3 sides, and if I want angle E is contained between these 2 sides, and I have the angle across from it, so I'm going to use cosine law. So as we're using cosine law with an obtuse triangle, I want you to think about what that means. Okay, so I'm going to set up the cosine law for the letters and the numbers I have. I want to find angle E, so I'm going to set up cosine law for E. So I'm going to say E squared equals D squared plus F squared minus 2D F cos of E. Remember cosine law. The front, this is an E. The front and the back always match. That's the way you set up cosine law. So once cosine law is set up, I'm going to plug in my numbers. Now E. Here's big angle E, so this is small side E. If this is big angle D, this is lowercase d, and over here is lowercase f. Okay, so E squared, 20 squared equals D, 12 squared plus f, 9 squared minus 2D f cos of E. E is what we're trying to find. Okay, so let's convert some of my numbers. 20 squared, 400. 12 squared, 144. 9 squared, 81. And then 2 times 12 times 9. Here, let's go to the online calculator. 2 times 12 times 9, 216. All right, work with my pen. 216 cos of E. Okay, I can group 144 and 81. So I have 400 equals 144 plus 81, which is 225. 225 minus 216 cos of E. I need to get rid of that 225, so I'm going to minus 225 from both sides. So I have 175 equals negative 216 cos of E. I want to find angle E, so I'm going to isolate it. Divide by negative 216. Divide by negative 216. All right, so I'm going to get the cos of E is a negative value. I'm going to get 175 divided by negative 216. I'm just doing it on my calculator. Negative 0.810 equals negative 0.810. Now, it's negative. Does that make sense? Are cosangles in quadrant 2 negative? Yes, they are. So that makes sense. If cosine's negative, it means it's an obtuse angle that ends up in the second quadrant. So we're going to go to the calculator. Let me get that 175 divided by 216. That's negative, just so I can get that on that calculator. Okay, there's that negative 0.810. It's a cosine ratio, so second quadrant because it's negative. So second cos of that, and look at there, 144 degrees, which makes sense because it's a negative cos ratio. So angle E is 144. Okay, good luck in section 4.2. Ask questions as you need.